Hey, 7th graders, Mr. Vickery here with day one of your 7th grade science test prep. Some of you are wondering maybe what I look like, what do I do here? Here I am. Here's a video of me. Anyway, kind of the same format. We're going to look at some questions. We're going to give you about 60 seconds per question to read it, think about it, and come up with an answer. After that 60 seconds, I'm going to go through the thought process of how you get to the correct answer on those questions. Teachers, at any moment, if you feel like the kids need more time or you want to talk about the question, you can hit pause at any time and go through those questions together. I'm going to let you, so we'll just start with the 60 seconds. After 60 seconds, I'll go into my explanation. Your first question starts now. All right, if you guys are ready, here we go. Ramon set 2 glasses of water outside next to each other for 15 minutes. A lot of times I like to highlight some of the most important information. Each glass had the same amount of water. One glass was covered with black paper, and one was covered with white paper. He took the following temperatures. So he's running an experiment, and every so often here, at 1 minute, 5 minutes, 10 minutes, 15 minutes, he's measuring the temperature. So after 1 minute, the temperature is exactly the same. 2 minutes, you can see the one with the black paper is getting warmer. And in every case, it's warmer. Really, all that stuff is kind of beside the point. So you have this great data table. What is the question asking us? It says, what is the variable being tested in this experiment? So regardless if you can interpret the information given or not, we need to know what is the variable being tested. A variable is something that has been changed purposely. So if we look at the experiment, each trial or each um, piece of the experiment here has a glass with the same amount of water. What's different is what you got to ask yourself. Well, the difference is we covered one with black paper and another one with white paper. We wanted to see what the difference was. Clearly something's happening. The black paper is getting warmer. We don't really have to explain it, but we do need to know that the color of the paper is the variable. So letter A is our choice here. Your next question, you will have 60 seconds starting now. All right, here we go. Manufacturer is conducting research using a hammock they want to sell to consumers. The manufacturer places different amounts of mass, that's a key word here, on the hammock and observe what happens to the hammock. So ask yourself, what is mass? Mass is like, could they be putting bricks? Perhaps bricks have mass. Why would they be putting more mass onto the hammock? Why would they continue to pile these bricks on there? What could they possibly be testing? So we read the question. So a lot of times I like to look at what's going on, go to the question, which feature of the hammock is the manufacturer most likely testing? So let's take a look at our answers. The force required to break the ropes. So I'm looking at how many bricks do I have to put on this hammock before the ropes break. The force required to swing the hammock. Not sure if that's really the case, swinging back and forth. The color and style preference of consumers. Ask yourself, why would they need to put bricks on it to see if customers like the color? The damage the hammock caused by the sun. Again, ask yourself, why would they put bricks on it to see how the sun affects this hammock? The answer is, well, think about people come in different sizes and shapes. Wouldn't you want to know how much weight the hammock can support? So if we just put masses in there to test the strength of the hammock, that would give us a lot of information. So letter A is the best choice. Next question. Ready, begin. Alright, so we have a scenario here. Tim rolled marbles down a ramp to discover how far the cup would move as the marbles were added. So in other words, if you were to roll a marble down this ramp and it eventually hits the bottom of this cup, you, without knowing anything about science or this experiment, what do you predict would happen? Well, the cup is going to move. How far does it move? Well, the data table tells us here. If we put one marble in, it looks like it moved about 2 centimeters. And your prediction is if I rolled another marble at the same time and they both hit the bottom, it should move farther. And in fact, the data here backs that up. It has moved 3 centimeters with 2 marbles. And continuing, we don't have, if we added another marble here and rolled it in at the same time, it moved 4 centimeters. And add a fourth marble, it moves 5 centimeters. The conclusion is, what can we conclude from the data that we collected here? Read the choices. Which one makes the most sense? Using more marbles made the cup move farther, which is distance, which is centimeters. This one sounds pretty good. Using fewer marbles made the cup move faster. Think about that. Does that even make sense? Fewer marbles moving faster. I could argue if you put more marbles it would move faster. So I'm going to throw B out. Gravity moved the cup no matter how many marbles were used. Gravity, this one just doesn't make sense. Friction stopped the cup when no marbles were used. What's tricky about this last statement is it is true, but is that what we're testing in the experiment? The choice here is what relates to the data. Your conclusion has to relate to whatever data you collected, and that is what we have there. Next question, 60 seconds. Ready, begin. All right. Miguel wants his toy car to reach the bottom of the ramp as fast as possible. Which ramp will result in the fastest speed? Um, Here's the thing. You guys all know enough about science. We need this ramp here to be as smooth as possible. So think about which one of these surfaces would be smooth. Well, a carpet, you've all tried to roll something on carpet. Doesn't work very good, so I'm going to throw that one out right away. Wood is pretty smooth, and I think a car would roll pretty good on that. Well, let's check the rest. Sandpaper. If you don't know what it is, it's kind of like a real gritty, it's got sand glued to it. Uh, would you think this would be faster or slower than, say, a wood ramp? I'm hoping you said slower because I'm going to cross that out. Cork, you may not be familiar with, is sort of like wood, but if I've ever felt like a cork that comes out of I don't know, a bottle, it's kind of rough. And I know that's, if you haven't seen that, it's kind of rough. So I'm thinking, would cork be the best? I'm guessing no. So I'm going to just say that a wood ramp would be the best for the fastest surface. Next question, 60 seconds. Ready, begin. All right, here we go. An experiment was conducted to determine the feeding rate. Let's see, feeding rate. What does that mean? How fast something eats? I think that's probably a fair guess. At which two different water beetles eat frog eggs. The data are shown in the following graphs. Let's see if we can interpret what this graph actually means. So over here on the left side it says total number of frog eggs eaten. So as I move up in this direction, that is more frog eggs. Okay. So, and time is moving along this axis. So as time goes by, I'm eating more frog eggs, apparently, is just what this graph says. How many, let's get to the question now, how many frog eggs did Beetle B eat in the first 4 minutes? So how a graph works, so Beetle B, if we look over here, the data is this pink circle. So when the time begins, Beetle B starts munching away, and he's munching away, and he's munching, he hits to 10. In 1 minute he's eaten 10. He keeps eating, he's not eating 10 more, he just continues to eat along his path, and after 2 minutes he's eaten now 20. See where we're at? We're lined up. He keeps going. He's still eating. He's trying to get full as possible. He eats, and now he's hit 30. So after 3 minutes, he's now eaten 30. What's happening right here in this stretch? At this point, Beetle B is full and not eating any more eggs. There has to be a limit to how much Beetle B can eat, and that we hit it. It was at 30. So after 3 minutes, still 30, 4 minutes, 30, 5 minutes, 30. He has not eaten any more. So after 4 minutes, we go here, we look at this point, we move over to here, Beetle B eating 30 eggs. There we go. We do not add these numbers together, which is what they want you to do. Next question, 60 seconds, begin. All right, in a food chain, which are the most efficient users of solar energy? So a couple terms we have to know here. Food chain. Food chain is like, well, here's the sun. Sun shines down on the earth. Here's the earth. Plants. See if we can draw a plant here. It's kind of fun. Here's a flower. Flower absorbs the sun's energy, and then an animal will come along, eat the plant. We'll draw. Here's a little. What's this going to be? It's what do you want to? This dog comes along, eats the plant, and then so that's kind of the start of a food chain. Either which way, some more vocab to know here. Herbivores, carnivores, omnivores, parasites. What's an herbivore? Vocab says this is a plant. This is a meat eater for carnivore. Omnivores eat both. Parasites, I'm not sure how you'd classify that. I suppose could be both as well. So which one uses the sun's energy? Well, we know that plants or herbivores are the ones that are collecting that solar energy. So the choice is A. Next question, 60 seconds, begin. All right, got two groups of animals here, Group A, Group B. At first glance, they may seem similar, they may have some differences. Let's see what the question says, maybe give us a couple clues. Why were these two animals placed into these groups? So each group is unique in some way. So let's read the choices. One group is active during the day, the other group is active at night. You may not know the answer to this question based off of what you know about these animals, but I will say this. Let's read through the other choices and just make sure, and then I'll tell you what the right answer is. One group lives near prairies, the other lives near forests. Perhaps one group benefits people, the other group is a pest to people. One group eats only plants, the other eats only meat. So what we're looking for is which one of these statements best describes. The answer, I mean, without spending a ton of time on this, owls, when do they come out? At night. What do they eat? Well, they eat meat. Opossums, when do they come out? Night. What do they eat? Plants. Moth, when do they come out? Night. What do they eat? You know, I'm not even sure. I think they eat like, what do they eat? Nectar? Maybe. We'll see. Bats, what do they eat? Bugs, when do they come out? Night. That's the part you may not know, but all four of those come out at night. These things here all come out during the day. It's not like you couldn't possibly see them at night, but they're not nocturnal. They do eat a variety of different things. But the common thread here is these are nighttime animals. So I like choice A the best. Next question, 60 seconds, begin. Alright, green plants are important to animals because the plants, and one of these statements must be true. Consume food and give off oxygen, consume food and give off carbon dioxide, produce food and give off oxygen, produce food and give off carbon dioxide. Well, we have to look at what the meaning of these words. Consume means to eat or use. So, and produce means to make. Plants take energy from the sun, make food, and as a byproduct, they give off oxygen. We need both of those things. We need food, we need oxygen to breathe. Letter C is our choice.